All right, today we're talking about adding and subtracting rational expressions. We are adding and subtracting fractions. This is the hard stuff. This is the hard stuff. So, I don't know, anybody want to volunteer? What's 2/17 plus 3/17? Megan? 5 over 17. Yeah, when you add or subtract the fractions, only add or subtract the tops. Now let's write some rules down. Whoops, I'm not talking. Hold on, let me put the other thing up there. Sorry about that. I posted the notes up. So let's go over the rules for adding or subtracting fractions. First of all, you only add or subtract the tops. And the only time you can actually ever add or subtract the tops is if they have the same denominators. Hold on. All right, so now we're going to be adding, we're adding two fractions, but they don't have the same bottoms. They don't have the same bottoms. Like, check it out. Bottom is 14 here, bottom is 7 here. Now, you can only add or subtract two fractions if they have the same bottoms. So, anybody remember what you have to do from algebra? No, you can, that's a great, everybody always wants to cross multiply. You can only cross multiply when this is the case. If there's an equal sign in between. So no cross multiplying. Got to make it the same. Megan, what do we do? Yeah, we got to find, well, I don't know about finding the greatest common factor, but basically what we have to do is you have to multiply by something that will make this fraction the same as the other. So what are we going to multiply it by? Times 2, but times 2. So what we're going to do is, we're going to multiply this fraction by 2 over 2. And then check this out. We got 2 over 14 plus 24 over 14. And now they have the same bottoms, and you just add them. What do we got? And we're done, right? Very nice. What are we going to simplify it into? What's up? Yep, you could simplify it by 2, so that's the same thing as saying 2 goes into 26 13 times, and 2 goes into 14 7 times, so the final answer is 13 over 7. Very nice, man. Very nice. Guys, so here we go. We're going to move away from just being pure numbers. We're going to start to move towards algebra, and now we're going to move pretty fast now that we got the hang of it, okay? So do the x's just erase themselves? No. Because this is like 1x. So yeah, so it's 2x over 4. Yeah, and we're going to reduce. What does that reduce down to be? Yep, we got 1x over 2. Are there any questions on that? That's it. Guys, what about this one, right?
8 over x.
So we talked about it, right? We talked about it. Check it out what happened in this one. When we subtracted them, did you subtract the bottoms? No. What about this one? Are we adding or subtracting the bottoms ever?
No, I forgot.
Nope.
8 over x, like Kevin Darden said.
It's like 8, it's 8 over x, just as Kevin Darden said. Yeah. We got a new problem. Megan's going to do it for us. Go, Meg. Show us how to do it. All right. So check it out. What are you doing? Multiplying by 2. Why, Megan?
It has to be the same denominator.
Yep, because it has to be the same denominator. Let's keep going. All right, Megan. So Megan multiplied the second one by 2 over 2. And look what she got. She got 4x over 6. Subtract the tops, 1x over 6. Guys, what do you think about Megan's work? Good job. Good. Way to go. Way to go. All right. New problem. Kev? You ducking out on me? Who wants to take Kevin's spot? Any brave volunteers? What's up? That's Hannah, you going to try? Okay, all right. So here we go. So I'll try. So let's take a look at the bottoms, right? Let's take a look at the bottoms. I'm going to circle this one and I'm going to circle this one. This is sometimes what I do and how I organize the information. I'm going to write them down over here. I got 2x squared and I got 3x, right? What do you have to multiply this one and this one by so that they'll have the same kind of stuff? Right? Well, 2x squared is just 2 times x, and this one is 3 times x. So at the very bare minimum, right, I have to multiply the 3x by what?
2x.
Yeah, I mean, that sounds like a good idea. Look, we're going to have to multiply by 2 and by x. So times by 2 times by x. And what about the top over here? What do you have to multiply it by? Just by 3. Awesome. And at the end of the day, what do you get when you multiply all this stuff out? 6x squared. And what about this one? 3 times x times 2 times x. Yeah, 6x squared. All right. Whoops. And let me fix something because it's not correct. It's not correct mathematically. I'm going to put these two symbols. You know what those are? Those like little dots? Yeah, do you know what they mean? It's like a pause. Is that confusing to some people? Yeah. So I'm multiplying this side by 2x over 2x. And I'm going to multiply this side by, what am I multiplying this one by? Just by 3 over 3. And you're always multiplying top and bottom by the same thing. Okay, so let me erase this business over here. Let me just erase. We get 9 over 6x squared plus 8x over 6x squared. And what's 9x? What's 9 plus 8x? I mean, the problem is it's not 17x because this one doesn't have an x next to it. What's 9 plus 8x? Nope. It's just 9 plus 8x because those are not like terms. Very nice. Over 6x squared. And now we have to think to ourselves, self, can we reduce that? Tell me why or why not? What's up? What's the rules for reducing? They all got to have the same thing. Do all of these guys have the same thing? No. You could have reduced it if the 9 had an x, but they all have the same thing, so that's where we stop. That one was hard, right? Guys, we are stepping it up big time. I'm telling you right now, that's an Algebra 2 trig problem, but I think you could do it. So let's think to ourselves. First of all, you say to yourself, can I add or subtract them? Do they have the same bottoms? No, they don't have the same bottoms. If they don't have the same bottoms, then you got to multiply by something that makes the bottoms the same. And you think to yourself, what does one have that the other one doesn't have? This one right here, this one on the left is m plus 1, and this one on the right is m minus 1. Any ideas for what to multiply by? Nope. Here we go. Real hard problem. It turns out the only thing that you can multiply by is exactly the opposite. In other words, this one over here was m plus 1, so I'm going to multiply this side by m plus 1, and then it'll have the same bottoms. Guess what I'm going to multiply this side by? Very nice. Was that what you said, Jose? Oh, I didn't understand what you meant. Oh, that was excellent, excellent. And so now let's do this. And you don't actually even have to multiply these two together. You can just leave it like that on the bottom. This is the most useful way to take care of it. M minus 1, and then this is m plus 1. Now what's 9 times m minus 1? This is 9m minus what? The 9 gets distributed inside. It's 9m minus 9. Yeah? And what about the other one? So the other one is going to be this. After this problem, we'll put some problems up on the board. You guys will be free. You guys can work for 10 minutes on your homework. So come on, let's work it out. It's the last one we're going to do together. The 6 gets distributed inside. Well, so what does the top become? 6m plus 6. And now here's why this particular problem is so tricky. It's because, right, you're going to subtract the tops. Here's what you have. You have 9m minus 9 minus 6m plus 6. And the reason you have to put this in parentheses is because of this minus sign right there. Guess what we're going to have to do to that minus sign? Yeah, and that's a real annoying part, and everybody always forgets it. M minus 1, m plus 1 equals, so this we're going to distribute the negative, right? You're going to get 9m minus 9 minus 6m minus 6 all over m plus 1 and m minus 1. This is a lot of work. This is why I was real careful today about how we went about trying to do our notes. We are no longer in the easy stuff. Now let's check it out. Let's check it out, right? Here's where we came from. Now we're going to combine like terms. This and this go together, and then these two are going to go together. 9m minus 6m is 3m. Negative 9 minus 6 is negative 15. All over m plus 1, m minus 1. Oh, we're not done yet. We got one last step to do. One last step to do. No, well, you have to check to see if you could reduce it. So, Hannah, what are we going to do? We're going to factor the top and see if anything will cancel out. That's 3 times m minus 5. Does anything reduce with the bottom? So that's how you know. If nothing reduces with the bottom, you are good to go. Ay, 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 ay. Dios mío. Yes, because you can do all that, because you guys are real smart and you can do it. And there's your homework.